So like I said, this is our last set of notes for this chapter. There's 2 or 3 things we're going to be looking at. The first 2/3 of these notes are review, and you've seen them before. The last third is new. Okay, first thing that we are going to review is writing the equation of a line. There's a whole bunch of forms of lines. The first one is the one that most of us use most commonly, and that's slope-intercept form. Y equals mx plus b. Not particularly helpful because you have to have the y-intercept, which is often not the case. There's also standard form where a and b are on the same side. Let's just cross that one out. You need to know it, but it's very rarely used. You will never actively choose standard form. You might be given standard form, but you wouldn't choose it yourself. The form that is most frequently used is point slope form. So that one I want you to put a star next to, because that's the one that you're going to use most often. It's called point slope form because it uses any point, x1, y1, and it uses a slope, which is m. So it's in the name. The 2 specialized ones that students tend to forget are vertical and horizontal lines. You do not need to have these memorized. If we picture a vertical line, let's say something like this. Let's say that is our line. As you can see, it's x equals some number. It goes through the x-axis. That's why it's x. So in this point, it goes through the x-axis at 2. The equation of that line then would be x equals 2. Horizontal line goes through the y-axis. So you don't need to memorize those. Okay, we are going to see how to use these in example 1. There's a few different parts to it. Example 1a, write the equation of a line that is parallel to the x-axis and passes through -2, 10. In my opinion, this is the hardest one out of the 3. I think it would be helpful to sketch it out so we know exactly what's happening. If we go to sketch this out, -2, 10, it doesn't have to be exact, but -2, 10 is somewhere up there. And then we are writing the equation of the line that is parallel to the x-axis. This one, the horizontal, is the x-axis. So this is the line that we are writing the equation of. So it's a horizontal line. Horizontal and vertical are always x equals or y equals. All you have to look at is which axis is it going through. This axis right here is the y-axis. So our equation will be y equals. And looking at our point, it's just the y coordinate. So y equals 10. That's the entire answer. And that's because every point on this line has a y value of 10. So that was A. B, write the equation of the line that is perpendicular to that line and passes through for -7. Okay, write yourself this note real quick. Parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. So the line that we have, we need to figure out the slope, and then the perpendicular line will have the opposite reciprocal slope. Okay, the line that we have is in standard form. This is not particularly helpful because it doesn't give us the slope. So what we're going to do is we're going to put it in slope-intercept form. We're going to solve for y. Then we'll be able to figure out the slope. So what I'm going to do is I'm going to subtract 2x. So when I do, I get -18 minus 2x. Please make sure you keep that negative with the 6. So it's not 6y equals, it's -6y. Now I can divide by -6. Everything gets divided by -6. Some of you did this wrong on the quiz 2 days ago. Everything on the right side gets divided by -6. So -18 divided by -6 gives us +3. -2 over -6 is a positive 1/3 x. So this is slope-intercept form. It's written a little funky. Y equals mx plus b. So for this line, our slope is 1/3. It's always what's in front of the x. That means then that our perpendicular slope, we flip it and change the sign. So we get a -3/1. So now we are ready. We are writing the equation of the line with a slope of -3, and that passes through 4, -7. As much as we like slope-intercept form, y equals mx plus b, we can't use that here because we don't have the y-intercept. So instead, we're going to use point slope because we have a point. So we get y minus -7 equals -3 times x minus 4. So y minus y, that -7 comes from our point. -3 is our slope. 4 comes from our point. I do not want to leave the minus and negative. So instead, that becomes y plus 7 equals -3 times x minus 4. Leave your answer like that. Leave it like that. Don't change to slope-intercept. You can, but there's no reason to do extra work. I'm perfectly fine if you leave your answer like that. If you want to switch to y equals mx plus b, you can. You're just doing extra work. Okay, last one. Write the equation of the line that passes through 7, 11, and 2, -1. Okay, for the equation of any line, we are always going to need slope. So in this case, where we aren't given slope, we have to find slope. So that's what we're going to do. So remember with slope, we start by subtracting our y's. It doesn't matter the order that you go in. So I'm going to do 11 minus -1. So y minus y. Then we're going to have to do x minus x. So that's 7 minus 2. In the numerator, that minus and negative changes to a positive. So we end up with 12/5. That is our slope. We're going to use point slope form again. In this case, we have 2 points. You can choose whichever one you want. I'm going to use the first one because it doesn't have any negatives. So then I get y minus 11 equals the slope, so 12/5 times x minus 7. And that's it. Leave your answer like that. That being said, you also could have used the other point. And that's what you would have gotten. Either of these are acceptable answers. Either of those are equations for the same line. That was the first thing we needed to review, was equations of lines. Questions before we move on? Okay. Next topic. We are looking at equations of quadratics. So to remind you, a quadratic has an x squared. The highest power is an x squared. There are 2 different forms of a quadratic function. You can see the one on the left. That one is generally not very helpful. We prefer the one that's on the right, that's called standard form or vertex form, because it gives us the vertex right away. So what we're going to be doing is we're going to be taking equations that are in the left form and changing them to the form on the right using completing the square. We're going to do an example together and then you all are going to try one. So it says find the standard form of a quadratic by completing the square, state the vertex, then state the maximum or minimum. Okay. Ooh. Here's how I start. Bless you. We've already reviewed completing the square. The first thing we did is we kept x on one side and we moved everything else to the other side. So I want x squared and this x on the same side. This 5 that I don't need, I'm going to move it on over. So So if I do that, I get f of x plus 5 equals x squared minus 2x. With completing the square, this is the one where you have to add something to both sides. So that's what I'm going to do. The space is where I'm going to add something. To figure out what that quantity is, it's going to be exactly the same step as you did before. So you're going to take that b value, divide it by 2, and square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Positive 1. If I do this correctly, the right side should factor. Looking for two numbers that multiply to 1 and add to negative 2. What are those? Multiply to 1 and add to negative 2? Negative 1 and negative 1. So that is x minus 1 times x minus 1. If you remember, those numbers should always be the same. So that becomes x minus 1 squared. Okay, and then on the left side, I end up with f of x add 6. And that's because 5 add 1 gives me that 6. So I'm not quite done yet. I have one more step. I want f of x alone. I don't want the 6 there. So I have to move the 6 back to the other side. So we get f of x equals the quantity x minus 1 squared minus 6. So that is our final answer. That is our quadratic in standard form or vertex form. This initial equation in black and this equation that I just boxed represent the same quadratic or the same parabola. The question asks us, though, for the vertex and the maximum or minimum value. If we look back at the equation, it's very important that you note these signs. First one is negative, second one is positive. Here's why that matters to us. When we are finding the vertex, this inside sign we have to flip, but the outside one we can keep. We flip because of the subtraction. So our vertex then, instead of negative 1, it's going to be positive 1, negative 6. So always flip the sign that's in parentheses, keep the sign that's outside. Lastly, we have to state the maximum or minimum value. Here's how you do that. Whatever number is out in front of the parentheses, nothing's written there, so that's a 1, tells us how the parabola opens. So that 1, since it's positive, tells us that the parabola opens up. So we have something like this, a parabola opening up with this vertex being 1, negative 6. This parabola then has a minimum. It has a low point. So we would say it has a minimum. It is not the entire point, though. If we look at this point, as we go this way, x is getting smaller. X is getting smaller. We're going that way. So x is getting smaller. X does not have a minimum then. Y has a minimum. So we say that the minimum is negative 6. So you might want to write that maximum or minimum is only the y value. Only the y value. If you write it as a point, I will not give you credit. As we look at B, how is the equation in B different than the equation in A?
It's not 1x
It's not 1x squared. That's a really big deal. It's a really big deal that we have this negative 6x squared. That being said, we're going to start out the same way. We want x on one side, we want everything else on the other side. So the first thing that I'm going to do is move that 11 on over. So I get f of x minus 11. And then I'm going to need to add something. And I have negative 6x squared, add 60x. Do you remember talking about how you can only complete the square with a 1x squared? Has to be a 1x squared. Charlie, do you have a suggestion or a question?
Oh, I was just saying a suggestion.
What's your suggestion?
Take out that negative 6.
Yeah, it's exactly what we're going to do. We cannot complete the square with a negative 6x squared. What we can do, though, is factor it out. So that's what we're going to do. We end up with an x squared, subtract 10x, and then we still have that space. Left side stays the same. So we have to figure out what to add to that space. You're going to take that b term, divide it by 2, and square it. So this ends up being negative 5. Negative 5 squared is positive 25. Okay, here's where I need us to be careful. On the right side, we didn't really add 25 because we still have that negative 6. So you have to picture distributing the negative 6. Negative 6 times 25 is negative 150. So that's really what we added. We didn't add 25. We added 25 times negative 6, which is negative 150. That's what needs to go here then. So that number is the negative 6 times the 25. And now we're going to proceed like normal. On the right side, this should factor. So two numbers that multiply to 25 and add to negative 10. Negative 5 and negative 5, like we said, should be the same number. So we get x minus 5 squared. On the left side, if I combine the negative 11 and the negative 150, I get negative 161. So then lastly, move that 161 back, and we get f of x is equal to negative 6 times the quantity x minus 5 squared, add 161. Okay, so again, the equation in black and the equation that are boxed represent the same parabola. So they represent the exact same parabola, just in different forms. Now, when we go to find our vertex, we talked about it's this number and that one. And remember we said flip, keep. Okay, so flip, keep gives us 5, 161. So that's our vertex. No, second one we keep.
Oh yeah, we flipped those down.
Yes. Okay, so then lastly we have to figure out if we have a maximum or a minimum value and where that occurs. That is based on the number out in front. What we care about is that that number is negative, which tells us that our parabola opens down. So we are looking at something like this. That is our vertex. If our parabola is opening down, it has a high point then. That high point is called a maximum. So we say that this parabola has a maximum, and it is always the y value, which in this case is 161. Again, I do not want the entire point. I only want the y.
So for the minimum or maximum, it'll always be y.
Always y. Okay, that is completing the square to change the form of the quadratic. So it should be pretty similar to the other completing the square with a few minor adjustments. Any questions for me? Charlie? Yeah. Next thing we need to talk about. So there's two more topics. One is function notation. And we've done the function notation before. This has to do with operations on functions. This should be pretty clear. If we're looking at example 3, we have this function f of x and we have another function g of x. We're finding 4 different things. In A, this tells us that we're adding the functions. So we're adding the functions to make a new function. And if you remember this notation, the input is going to be 3. So the input is 3. It's asking us what the output is. We are going to start by adding our functions. So if we add them, we get x squared plus 2. That's f. Add 3x minus 1, which is g. If we go to simplify this, 2 and negative 1, so this will be x squared, add 3x plus 1. The order doesn't matter. We have to remember, though, we still have an input of 3 to deal with. So now, we're going to put 3 in. When we do, we get 3 squared, add 3 times 3, add 1. So this is 9, add 1, which is 19. So that is our final answer. In B, this time we are subtracting. From the notation, we can tell the input is x. So we don't actually have any number that we're plugging in. We're just going to simplify. Our f is x squared plus 2. And we are subtracting then g, which is 3x minus 1. Please be careful here. This is what most of you do, which is wrong. What am I missing? Parentheses. Parentheses. We need those parentheses. Why does it matter? Why are the parentheses necessary? I'm going to have to distribute the negative. So we get x squared, add 2, subtract 3x plus 1. Combining like terms and changing the order, I get x squared minus 3x, add 3. And again, our input is x, so we don't need to put anything in. One thing I want to point out to you, if your input is a number, like an A, your output should also be a number. If your input is x, your output should be in terms of x. So always make sure that that's the case. In C, our input is a number, our output should be a number then. In D, our input is a number, so our output should also be a number. Okay, in C, it's telling us to multiply and then use an input of 4. If we multiply, we get x squared plus 2 times 3x minus 1. Okay, let's be careful here. We want to be efficient, right? We don't want to do extra unnecessary work. What we could do is simplify that right now, or we can plug in 4. So let's plug in 4. Let's not bother to simplify. Let's plug in 4 first. because it'll be easier to simplify. So we get 4 squared plus 2, and then we get 3 times 4 minus 1. So that 4 squared plus 2, 16 plus 2 is 18. And then the second set of parentheses, we get 12 minus 1. 12 minus 1 is 11. And lastly, we got to multiply 18 and 11, and I don't know what that is. It's 198. Thanks, Charlie. Again, input is a number, output should be a number then. Now, if we had multiplied these two binomials in the beginning and then plugged in 4, we're going to get the same answer. In my opinion, though, it's just going to be a little bit of extra work. Okay. Last one is D. You should notice that the notation in D is a little bit different. Here's what that notation actually means. A way to rewrite this, this is f of g of -1. So this is telling us to plug -1 into g, then whatever we get gets plugged into f. So we are going to start with this inner part, which is g of -1. So we get 3 times -1 minus 1, which is -3 minus 1, which is -4. That -4 then goes in to f. So we plugged the -1 into g. When we got that, it now needs to go into f. So now we're finding f of -4. Please make sure you don't forget the parentheses. So we get -4 squared plus 2. -4 squared is 16. 16 add 2 is 18. Okay. That is operations on functions. Questions? No? Okay. Last thing that we need to talk about is what's called a translation. This is new. I believe this is new for pretty much everybody here. The idea with a translation is you're taking a graph and you're moving it around. So you're taking a graph, you might be moving it left, right, up, down. Maybe you're going to stretch it or shrink it. You might reflect it. So that's what we're looking at. I think this table is a little bit confusing, so I'm going to explain it differently. If you go down to the bottom, this is what I want you to write. We have y equals a times f of x minus h plus c. I just chose different variables. I don't know why I chose those, but I did. That a, that h, and that c all do something to the graph. Here's what they do. Anything that is inside the parentheses with f, you need to know that this affects x. Anything inside the parentheses is always going to affect x. On our graph, x is left to right. So that h is going to move the graph left or right. Left or right. And it is always the opposite of the sign. So for example, if we had something like this, y equals f of x minus 2. It's in the parentheses with f, so that will affect x. If we think on a number line of -2, -2 is going to be which way on a number line, left or right? Left. Okay, it's the opposite though of what the sign is. So instead of left, this would move the graph right 2. So it's going to move the graph right 2. So that's that number inside. This number at the end, outside of the parentheses, so this one is going to affect y. It is going to move the graph up or down. This one, though, is going to be the same as the sign. So it's the same as what you think it's going to be. So if this new equation in red is the equation that we are looking at, the -2 is outside of the parentheses. That tells us that we're affecting y. -2 on our y-axis is going to be down. So this will move our graph down 2. And lastly, this number out in front. This is going to do 2 things. First of all, it's outside of the parentheses, so again, it affects y. It does one of 2 things. It can stretch or shrink the graph. So it can pull it up or smush it together. Or it can reflect the graph. It can do either one. And we'll see that in a later example. It is possible for there to be a negative in front of the x or a number in front of the x, but we are not going to look at that. Okay. Questions before we look at a few examples? Okay. Let's go on to the next page then. Okay, in example 4, it says given y equals f of x, describe how you would obtain the graph of the following. Okay, inside the parentheses is going to affect x. So it's going to move us left or right. Remember, the one with x is always the opposite of what you think it should be. So if we think of a number line, +4 is in the right direction. Opposite of that would be left. So to get this graph, we would move the entire graph left 4 points. That's the answer. Here's what I could also ask you to do. I could say that our graph specifically has the point 2, -1. So let's say that 2, -1 is on the graph of f of x. I might want to know, what is that new point on this graph? F of x plus 4. Well, that +4 affects x, and it moves x 4 points to the left. So if we're at 2 and we go 4 to the left, that would be the point -2, -1. Y is unchanged. Your homework could ask for one or the other. In general, how do we get the graph versus how does that one specific point change? Okay, example B. That -10 outside of the parentheses affects y. So that'll be up, down. It's exactly what we think it's going to be. Negative should be down. So this will go down 10 points. Down 10 points. Okay, so then with our point, that 2, -1, x is not affected, but y is. If we're at -1 and we go down 10, we would then be at -11. So again, I could ask you for that in 2 different ways. In C, that negative is outside the parentheses, so it will affect y. What it would do is it would take all the y values and multiply them by -1. So that means if y value was 2, it would all of a sudden become -2. If the y value was -3, it would become +3. So before we describe the general change, if we took our point 2, -1, it would make the y positive. It would become 2, 1. It multiplies the y by a negative. What that ends up doing, if we're changing all the signs, picture here, all of our y's go from positive to negative, negative to positive. That's a reflection. It's a flip of the graph. So it's a reflection over the x-axis. Okay. Last one is D. We got 2 more examples. In D, we have 3 things going on. What's inside the parentheses affects x. And then we have 2 things in this case affecting y. 1 piece affecting x, 2 pieces affecting y. You will always deal with x first. Always deal with x first. X is going to move us left, right. -5 we think to be left on a number line, but remember we have to do the opposite of what we think. So this will move us right 5. And then you're following order of operations. Order of operations, what comes first? The negative, multiplying by a negative, or subtracting? Multiplying. This negative, like we said, is a reflection. So first we would move everything right 5. Then we would reflect over the x-axis. And then that -1 at the end would move us down 1. So our new point, if we had 2, -1, we have to do all 3 of those, and we have to do them in order. So first, we have to move right 5. If we're at the point 2, -1, and we move right 5, x is getting bigger. So that would be the point 7, -1. Then we deal with the negative out in front, which affects y. That changes the value of y. So then this will become 7, +1. And lastly, we would go down 1. So that y value would become 0. That 7, 0 then is our new point. How do we feel about this? Here's what I want you to do real quick. Example 5 is how we can see this example in a different way. We need to draw a new graph. What I want you to do is take a minute and tell me what this translation will do. What does that +1 do, and what does that +2 do? So try that right now, please. Okay, anybody volunteer? What is that x + 1 going to do?
Left 1 up 2.
Okay, this will move us opposite of what we think it should be. So it's going to be left 1. That 2 is going to be up 2. So we have on our graph 3 points. That's how you're going to move them. Left 1, up 2. So if I start with this point at the very bottom, I will go left 1, up 2, which is this new point. Happens to be the point that was already there. We also have this point here, the black one that was underneath. That will go left 1, up 2. And then this last black point that I haven't moved yet, that will go left 1, up 2. When you connect the points, your graph should have the same shape as the original graph. If it doesn't, you did something wrong. So we're going to connect in the same order. Can't be a different order. Got to be the same order. And besides the fact that my lines are not very straight, my blue graph is exactly the same shape as the black graph, but I moved it left 1 and up 2. So those are the two ways that you're going to see these translations. 1, in words. 2, you're actually going to be carrying it out. Okay. Questions for me?